Welcome to Grade 8 Tutorial Class Quarter 1 Module 1. And this is Teacher Francisco, your math facilitator for the school year 2021-2022. This video will help you factor polynomials completely using different techniques. In all lessons, you are given the opportunity to use your prior knowledge and skills in multiplying and dividing polynomials. For Module 1, it contains the following lessons. First, factoring the greatest common monomial factor. Second, factoring the difference of two squares. Third, factoring the sum or difference of two cubes. Fourth, factoring the perfect square trinomial. And lastly, factoring the general quadratic trinomial. After going through this video for Module 1, you're expected to first, determine patterns in factoring polynomials. Second, factor polynomials completely and accurately using the greatest common factor. Third, factor the difference of two squares. Fourth, factor the sum and difference of two cubes. Fifth, factor the perfect square trinomial. And lastly, factor the general quadratic trinomial. What is factoring? Factoring is the reverse process of multiplication. In multiplication, 2 times 3 equals 6. But in factoring, the factors of 6 are 2 and 3. One of the factoring techniques that you're going to learn is factoring by greatest common monomial factor. To understand this, let us do some picture analysis. What is the common of these two pictures? Can you spot a common that is found in the first picture and in the second picture? Obviously, it is the apple. How to use or apply this kind of factoring technique? First, find the greatest common factor of the terms in the polynomial, and this is the first factor. Second, divide each term by the GCF to get the other factor. To further illustrate the concept of GCMF, let's try to explore the following examples. Find the GCF of each pair of monomials. A, 4x cubed and 8x squared. Letter B, 15y to the 6th power and 9z. Here is the solution. For letter A, what is the GCF of 4x cubed and 8x squared? First, factor each monomial. Then second, identify the common factors. Then find the product of the common factors, and that is now our GCF. For letter B, find the GCF of 15y to the 6th power and 9z. The same process. Step 1, factor each monomial. Second, identify the common factors. Then find the product of the common factors. Take note that 3 is the only common factor. Therefore, 3 is the GCMF of 15y to the 6th power and 9z. Notice that in the given examples, prime factorization is used to find the GCMF of the given pair of monomials. The next examples illustrate how the GCMF, or the greatest common monomial factor, is used to factor polynomials. First, find the GCF, or the greatest common factor of the terms in the polynomial, and this is the first factor. Second, divide each term by the greatest common factor to get the other factor. For example, write 6x plus 3x squared in factored form. First, find the GCF of the given polynomials. Therefore, our GCF is 3x. Second, divide each term by the GCF. Therefore, the factored form of 6x plus 3x squared is 3x as our first factor times quantity 2 plus x as our second factor. Note that in the given polynomial, the sign that separates the two terms is a plus sign, and therefore in the factored form, we will also use the plus sign. Our next example is you're going to supply the missing term. Number 1, 5x squared minus 10x cubed is equal to blank times quantity 1 minus 2x. The missing term here is our GCF. To find the GCF of the given polynomial, we will factor 5x squared and 10x cubed. Next is determine the common factors of the two terms, get the product, and that is now our GCF, which is 5x squared. In this example, there is a common variable of each term, and to get the GCF, we will choose the variable with least exponent. Now, to check whether our second factor is correct, we will divide each term by the GCF. That is 5x squared divided by 5x squared, the quotient is 1. Then the other term, 10x cubed divided by 5x squared, that is 2x. In this case, we have a minus sign. So therefore, in our second factor, we will use also the minus sign. Our second example, the missing term is the second factor. Try to check if we have the same GCF, which is 3 only, since there is no common variable in each term. To find the second factor, we will divide each term in the given polynomial by its GCF. That is 3a over 3. The answer is a, plus 6b divided by 3. The quotient is 2b, minus 9c over 3. The quotient is 3c. Therefore, the missing term is a plus 2b minus 3c. Last example, factor 50x squared minus 2y squared completely. Now in this example, our GCF is 2. Then to look for the second factor, we will divide each term by the GCF. That is 50x squared divided by 2. The answer is 25x squared minus 2y squared divided by 2. Quotient is y squared. Take note, our second factor, 25x squared minus y squared, is still factorable using another factoring technique, which is difference of two squares. To factor 50x squared minus y squared completely, that becomes 2 times quantity 5x minus y and 5x plus y. So you can now answer your 3 activities about factoring the greatest common monomial factor found in your module on page 13 and 14. Let's proceed to another factoring technique, which is factoring the difference of two squares. For you to be well guided on this lesson, recall first the topics about perfect square and special product of sum and difference of two terms in grade 7. Perfect squares are numbers or expressions that can be expressed to the power of 2. Examples. Number 1, 4. 4 is equal to 2 times 2 or 2 squared. Another is 9x squared is equal to 3x times 3x, or that is equivalent to 3x squared. Thus, 4 and 9x squared are perfect squares. Let's try this. Which of the following is a perfect square? 16, 12, 25, 8x squared, and 36y squared. The perfect squares are 16 because that is equivalent to 4 squared. Another is 25 because that is equivalent to 5 squared. And 36y squared is also a perfect square because it is equivalent to 6y squared. Whereas 12 and 8x squared are not perfect squares. Recall that in special product, the product of the sum and difference of two terms is the difference of two squares. That is, quantity x plus y times x minus y is equal to x squared minus y squared. Another example, quantity 2x plus 5 times 2x minus 5, the product is 4x squared minus 25. Another, quantity 3x plus 2 times 3x minus 2, the product is 9x squared minus 4. What is the difference of two squares? It is the product of the sum and difference of two terms. The following expressions are examples of difference of two squares. They are all examples of difference of two squares since the first and the last terms are all perfect squares, and the terms in every polynomial were separated by a minus sign. To factor polynomial using difference of two squares, first get the principal square roots of each of the two squares. Then, using these square roots, form two factors, a sum and a difference. Let's have some illustrative examples. Find the factors of the following expressions. First, x squared minus 36. Second, 18a squared minus 2. Third, 25x squared minus 9. Please be reminded that before applying any factoring techniques, always apply GCMF first. In example number 1, there is no common factor of each term. So, we will proceed to difference of two squares since each term is a perfect square and was separated by a minus sign. To factor x squared minus 36, we will get the square root of each term. The square root of the first term, which is x squared, is x. And the square root of the second term, which is 36, is 6. Using x and 6, form the sum x plus 6 and the difference x minus 6. Thus, the factors of x squared minus 36 are quantity x plus 6 and x minus 6. Second example, factor 18a squared minus 2 completely. Since there is a common factor of each term, we will apply first GCMF, or greatest common monomial factor, and the GCF is 2. Then, divide each term in the polynomial by the GCF, which is 2. So, the answer is 18a squared minus 2 is equal to 2 times quantity 9x squared minus 1. Since our second factor is factorable using by difference of two squares, the square root of 9x squared is 3x and the square root of 1 is 1. So, to factor completely, we have 2 times 3x plus 1 times 3x minus 1. Our next example, 25x squared minus 9, we will apply difference of two squares since there is no common factor of each term. To factor 25x squared minus 9, we will get the square root of 25x squared and 9. The square root of 25x squared is 5x and the square root of 9 is 3. Therefore, the factors of 25x squared minus 9 are quantity 5x plus 3 and 5x minus 3. That ends our discussion on factoring the difference of two squares. You can proceed now to your activities on page 14 and 15. This time, we will continue on the next factoring technique, which is sum or difference of two cubes. These are the formulas for the sum or difference of two cubes. For sum of two cubes, x cubed plus y cubed, that is equal to quantity x plus y times x squared minus xy plus y squared. For difference of two cubes, x cubed minus y cubed is equal to quantity x minus y times x squared plus xy plus y squared. The factored form of the sum or difference of two cubes is the product of binomial and trinomial. Before we will proceed to some examples, let's recall first on how to find the cube root of the given expression. Find the cube root of the following expressions. Number 1, 8x cubed. 8x cubed is equivalent to 2x times 2x times 2x, or 2x cubed. Therefore, the cube root of 8x cubed is 2x. Number 2. What is the cube root of 27a to the 6th power? 27a to the 6th power is equivalent to 3a squared times 3a squared times 3a squared, or 3a squared to the 3rd power. Therefore, the cube root of 27a to the 6th power is 3a squared. Let's now explore on how to factor polynomial using sum or difference of two cubes. Example number 1. Find the factors of x cubed minus 64. The factored form of this is the product of binomial and trinomial. Our binomial factor is taken from the cube roots of the first term, which is x cubed, and the last term, which is 64. The cube root of x cubed is x, and the cube root of 64 is 4. Then, copy the given sign. In this example, x cubed minus 64, we will copy the minus sign. And that is how to get our binomial factor. How to look for the trinomial factor? We will focus on our binomial factor. Get the square of the first term. Our first term is x. Square of it, of course, x squared. Then we will use the opposite sign. Since the sign of our binomial factor is minus, we will use the plus sign. To continue, we will multiply the first and the last term, that is x times 4, and the product is 4x. And lastly, to complete our trinomial factor, we will get the square of the last term, which is 4. What is the square of 4? That is 16. Therefore, the factors of x cubed minus 64 are quantity x minus 4 and x squared plus 4x plus 16. Second example, factor x to the 6th power plus 8y cubed. Since the first and last term are perfect cubes, we will use sum of two cubes. First, we will find our binomial factor before looking our trinomial factor. Get the cube root of x to the 6th power, and the answer is x squared. The cube root of 8y cubed is 2y. Then we will copy the plus sign. To get our trinomial factor, we will square the first term of our binomial factor, which is x squared. That is x squared to the 2nd power, or that is equivalent to x to the 4th power. Since in the example the given sign is plus, we will use its opposite sign, which is minus sign. Then we will get the product of the first term, x squared, and the last term, 2y. That is x squared times 2y. And the product is 2x squared y. To continue, to get the last term of our trinomial factor, we will square the last term, which is 2y. That is 2y squared, or 2y times 2y. And the product is 4y squared. That concludes our part 1 in factoring polynomials.